Hey everybody, this is Larry. This is me doing week 5 of the Leetcode Weekly Premium Challenge. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about today's poem or this week's poem. Yeah, I'm in San Salvador, so I'm a little bit tired. We'll see what's up. I don't know. we'll see. Today we have 1746, maximum subarray sum after one operation. Let's see what the operation is. You must perform exactly one. So you have to do exactly one, where you replace one element with square. Okay. Return the maximum not possible subarray after exactly one operation. The subarray must be non-empty. Okay. So the maximum possible subarray sum with no operations is just contains, right? So that's just contains algorithm, right? So then for this one, we have to figure out, okay, there's one number that we can use to square it. So there are two things you can do for squaring. One is squaring a positive number, and that is what it sounds like. You just make a number, a big number bigger, and the other is squaring a negative number, which makes it even better. I think if you know Cadane's algorithm, then this idea shouldn't be that bad. The idea is just that, well, now you do Cadane's knowing that you have one operation or you don't have one operation, right? And I think the way that everyone, I'm not going over Cadane's algorithm in much detail, but the idea is that so you have something like maybe best is you go to negative infinity, say, right? Don't know if you can hear the music. It's from like next door. Hopefully it's not too loud. But yeah, and then like you have for x in nums, and you have like maybe current is equal to negative infinity, right? So then current we add it to x. If current is less than 0, then current is equal to x, something like that, right? So that you always, because basically if yeah, you're looking at the current streak, and current is the best current subarray that you have so far, right? And then now if it's negative, if it's 0, that means that now we want to start a new subarray with this current element. And then no, even if it's negative, right? Even if x is negative, because then now you have at least one moment. And then best is you go to max best and current, and then you just return best. So that would be the thing if you do no operation, obviously, because we haven't done anything with operation. And I think this is roughly right. I'm a little bit worried and would like to check, just because I don't know. I mean, this already looks, no, that's right, I think. I mean, it's a little bit wonky just because why I feel like sorry, I'm still complaining about the UI. Like, I feel like I want to be anonymous, and like, I don't know, I don't want people to know that I'm studying this. In any case, what a useless use of my internet. I don't need to know this. Like, I don't need all these live component. Why anyway, sorry for digressing. I'm just like, this new UI annoys me. I don't need all this social aspect, and like, I'm paid for premium and they made it worse experience for me. I don't get it. Anyway, I need to figure out a way to get my money back, because like, I didn't pay to be annoyed. Like, if you're gonna give me all these silly features, then at least, like, you know, I don't know. Anyway, any case, okay, so you have this, and this would be Cadane's algorithm. I'm not, as I always said, I'm not gonna go over in detail, but here you can really kind of, so this is kind of like a way optimized version of writing it, right? The way that you can also think about writing it is just tops down. And tops down, you can maybe just say, naming things is hard, that's right. Maybe just get max, and you have an index, right? The index is just what it sounds like, the index, right? And technically, the way that I often do this is backwards, meaning from beginning to end, but the recursion pops up backwards, right? So yeah, so let's say we have n items, and then yeah, if index is equal to n, then what happens? That means that, well, we're done. So then we have return negative infinity, right? And that's because if you have no items, that's not even possible. So that's why. Otherwise, you can just do tick no tick, right? And here you can say, well, we have the current index number, or number added index, and we can either choose to start a new array with it, or we don't, right? Or maybe another way to think of it is that, yeah, we have something that comes back from the right side, and we go, okay, do we want to add this element to those subarrays, or the best subarray that's connected, or do we, just start a new one, right? So take maybe, just to be more precise, is take or like merge subarray sum with the right side with further indexes. So then that may be just like get max of index plus 1. Yeah, I think the two things that I'm mixing up here on the top down. I haven't done this top down in a while, honestly. So that is kind of no Gucci. Maybe this isn't quite the way to go talk about it. Because I think you need to, if I do it this way, I need to store two things, right? I think that's the TLDR. And the two things is that one is the merge subarray sum max, and then maybe we could do it, but it's just very yucky. So we want now to return two things. One is the first element returned is the subarray sum beginning at index, the best subarray, and then the second element returned is the best subarray sum, like to the right of index, something like this. I'm saying it kind of imprecisely, but hopefully that, you get what I mean, right? And of course you can also use some sort of global thing, but that's just funky when it comes to memorization. So yeah, so anyway, so then now you get like left best and maybe or best or something like this, right? Let's go to this, right? Yeah, and then now you can, I guess we always just do this, right? And then we merge it with the left side, which would be num sub index plus L best, right? Yeah, so that is going to be the new L best, maybe, right? So this is the tick tick, right? And then and then no tick is just skipping, so then it's just L best, right? Or actually you don't take the rest, but then you num sub index, right? So then now the new best is just going to be either tick, no tick, or like max of those two, right? And because those are the things that require the current element. And then the thing is the or best is just, well, it's max of or best or max of these tick, no tick of the result, right? So that's really the contains algorithms, right? So when tops down, I think, I forget, we want to return this element, right? Yeah, so this is still at least right for these things, right? And of course, as we said, we're going to add cache. It's right if there are no operations, I think, I hope, otherwise I'm confusing people. But now you do want to add a thing for one operation, and that's really simple right now, right? So now you just have a used, but then now you just have to enumerate the case as well, because then now this is not quite the same, right? Because then now you have tick, no tick. This is not using the operation, right? Because, well, we haven't changed anything because we haven't used it, right? So yeah, and we want to say maybe we go from 0, right? So we don't use it, everything looks the same, makes sense. And then now we want to use the operation. If we want to use the operation, how do I want to write this? Maybe I want to say, maybe I'll just put this in a for loop, right? Maybe that's just being too funky. But yeah. But I mean, it's just enumerations, right? So then using the operation, you can say, it's just messy. That's all. Used L best, and then use all best, yeah, is equal to get max index plus 1 used plus 1, right? And that's only if used is less than 1, right? So actually if it's exactly 0, then now using the operation we have this thing, and then tick is, or the new used tick is equal to right times itself, which is what we want, plus this thing, right? And then this is no tick, which is no tick. It's just same things, right? I think this is right. This looks very funky, honestly. But the reason is because LBest can be negative, and I think that's not super clear why that no tick can sometimes be better than tick, and in the same way that these things, right? And then maybe we just kind of yeah, like I just say new LBest is equal to this thing, right? And then new or best is equal to max of or best and new L best, right? And then now here you can just update it this way. You know, max itself, you tick, you no tick, and then new or best is equal to max new or best, or and now best, I suppose. I think this is right. It is a little bit confusing for sure. But yeah, it looks good for these two. And then let's give a quick submit. Maybe I missed some edge case, but I think that's the idea, right? Yeah, it's a little bit slow because I kind of wrote this in a way that is illustrative, or I hope this is illustrative. Like you can do it bottoms up for sure. Maybe that's the cleaner way to think about it. But I want to also give you an opportunity to kind of just think about it another way. And yeah, it's all Cadene's algorithm rolled out, so that's why it looks this way. And of course, this is going to use a lot more space and memory, or more space is memory, but you know, and it's recursion space as well, and all these things, because well, that's just the way it is with memorization. But if you had done it bottoms up, you could use a space optimization, right? Which is a lot less space used, which allows you to write this cleaner. And also as a result of not needing to allocate the space, it goes a little bit faster. And that's pretty much it. That is all I have for this one. Linear time, linear space is the way that I have it. If you check out my older solution, I hate this new UI. Where is this? I can't even show you easily. I don't know. Oh, there it is. That's actually not bad, even though it's terrible. But yeah, you could it's the same structure, but you know, that's why it's so much faster as a result. That is all I have for today. Let me know what you think. Thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.